In this section, we're going to look at units of measure. When we're looking at scaling objects and comparing sizes, units are going to be important. It's hard to compare two distances when one is in miles and the other is in kilometers, or to compare two weights when one is in ounces and the other is in grams. Some of you might remember one particularly bad example of mixing up units. In 1999, NASA lost a Mars orbiter because of confusion over units. One team working on the project had used US units of measure, and another team had used metric units, which caused their calculations to be off. The first thing we're going to look at is units of measure used in the US. The conventional units of measure that we use in the United States are called the US customary system. And this chart here has just got different units of distance that we use and how they're related to each other. So you can see that 1 mile is equal to 1,760 yards, or 5,280 feet, or 63,360 inches, and so on. And a lot of this section is going to be tables like this one with different units of measure and how they're related to each other. This chart has units of area, and you'll notice that a lot of these are the squared units of the units that we saw for distance. So my basic unit here is going to be the square mile, and I could write that as MI, the abbreviation for mile, squared. And then I've also got feet squared and inches squared here. This little squiggly equal sign here means is approximately equal to. So if I look at this, I notice that 1 square mile is equal to 27,878,400 feet squared, which is approximately equal to 2.8 times 10 to the 7th feet squared. So here they've rounded to 28 million and then written that in what's called scientific notation. So if I've got a number times 10 to some power, that's called scientific notation, and it's just a convenient way of writing big or small numbers. So if I wanted to expand that back out, I'd have 2.8 times 10 to the 7th, and that tells me that there are 7 digits after the decimal point in the expanded number. So I'd take that 2.8 and move my decimal place 7 places to the right. 1, 2, 3, 4, 5, 6, 7, and then just fill in those empty spaces with zeros. So that's equal to 28 million, which is what we expected. You can also have a negative power, so I could also have 2.8 times 10 to the negative 3, and that would tell me to expand that out. I need to move the decimal place 3 places to the left instead of the right, so I'd have 2.8 and move my decimal place 1, 2, 3. So that would be equal to 0.0028. This chart has units of volume, and these are cubed units of distances mostly. The ones in this first part are anyway. I've got a cubic mile, which I could write as MI cubed, and also cubic feet and cubic inches. Another way to measure volume is with gallons or quarts, and this tells me that 1 US gallon is equal to 231 cubic inches. And finally, I've just got this small table with my units of mass or weight, which are given in tons or pounds, where 1 ton is equal to 2,000 pounds. Another measure of weight that we don't see very often, it's used more often in the UK, is 1 stone, which is equal to 14 pounds. So you should be pretty familiar with those units. The other common system of measurement is the metric system, and this is the standard for use in science, industry, and commerce. The metric system was first adopted by France during the French Revolution in 1795. And originally, the fundamental unit of length, the meter, was defined to be 1/10,000,000th of the distance from the North Pole to the equator through Paris. So that's pretty specific and hard to measure, and they went to a lot of difficulty to actually get that measurement. Now the meter is defined to be the distance that light travels in a vacuum in this tiny fraction of a second, about 1/300,000,000th of a second. All of the other units of length, area, and volume are going to be defined in terms of the meter in the metric system. So let's go ahead and look at those. So my first table here has distances. I've got meters, centimeters, kilometers, and millimeters here. And you might notice that these are all related by powers of 10. So I've got 1 meter is equal to 100 centimeters, which I could write as 1 times 10 squared centimeters. A kilometer is equal to 100,000 centimeters, which is 1 times 10 to the 5th centimeters, or 1 times 10 to the 6th millimeters, or also 1,000 meters, which I could write as 1 times 10 to the 3rd meters. So this is pretty convenient, easy to remember since these are all some power of 10. Again, I've got my area table, and these are going to be mostly in units that are the squares of the distance units. So I've got square meters and square centimeters here. The odd one out here is going to be the hectare, which is defined to be, it's not defined in terms of distance units, but it's equal to 10,000 meters squared. And then I've got my volume, and the unit of volume here is the liter, which is equal to 1,000 centimeters cubed. So you can see again that I've got the cubic units for my distance units. So I've got centimeters cubed here, and also cubic meters. And finally, the measures of mass or weight in the metric system. We're going to use kilograms or grams, where 1 kilogram is equal to 1,000 grams, or 1 times 10 to the 3rd grams. And there's also a metric ton, which is equal to 1,000 kilograms. And be careful not to confuse this with the U.S. customary ton. They're not quite the same, though they're pretty close. So now that we've got all of those units, we need to know how to go back and forth between the U.S. customary system and the metric system. Since 1995, or 1959 rather, the fundamental units of the U.S. customary system have actually been defined in terms of metric units. So now 1 yard is actually defined to be 0.9144 meters, and 1 pound is defined to be this decimal of a kilogram, 0.45359237 kilograms. And these tables here give some helpful equalities between U.S. customary units and metric units. So we can see 1 inch is equal to 2.54 centimeters, 1 foot is equal to 30.48 centimeters, or about 0.3 meters. 1 yard is equal to 0.9144 meters, or about 1 meter. Now when you're doing your homework, you should use the more precise numbers here. So you should use this 0.9144 rather than the 1, and so on. And this chart's got some relations between units of area. So I can convert feet squared into meters squared or centimeters squared, and vice versa, and also hectares into acres. And I've also got relationships for volume, from feet cubed to liters, gallons to liters, meters cubed to gallons or feet cubed, etc. And finally, for mass or weight, I've got 1 pound is equal to this number of kilograms, which was actually the definition of a pound now, which is about half a kilogram. So 1 kilogram is equal to about 2.205 pounds, which you can round to 2 pounds for a rough approximation. And using the same idea, 1 metric ton is actually equal to 1.1025 US customary tons. So they're not quite the same, but that's pretty close. So now we've got all these relationships. We want to be able to convert one unit into another, and we're going to use a conversion factor to do that. A conversion factor is a quantity that's equal to 1 that we can multiply a measurement by to cancel the original unit and leave the new unit. So for example, I know that 1 kilogram is equal to 2.205 pounds from my table up here. So if I divide both sides by 1 kilogram, this means that 1 is equal to 2.205 pounds divided by 1 kilogram. And this is going to be a conversion factor that changes kilograms to pounds. So I've got the pounds on top and the kilograms on bottom. So if I have an object that weighs X kilograms, then if I'm multiplying it by the conversion factor, that's the same as multiplying by 1, so that's not going to change the quantity at all. So that's going to give me X kilograms times 2.205 pounds over 1 kilogram. Now I can cancel, just like I can cancel numbers, I can cancel units. So I've got this kilogram, which is on the top, and this kilogram on the bottom, and I can cancel those. And that's going to leave me with X times 2.205 pounds. So let's look at some examples. For my first example, we're going to convert kilometers to miles. Suppose that you're vacationing in Italy and you want to go for a short hike in the Alps. You have a brochure with several options, but the lengths of all the hiking trails are given in kilometers. One promising option is a moderate hike of 4.7 kilometers. How far is that in miles? Well, first, if we go back and look at our distance table, we can find that 1 kilometer is equal to 0.621 miles. So I'm going to use this to get my conversion factor. So if I divide both sides by 1 kilometer, that's going to give me 1 is equal to 0.0621 miles divided by 1 kilometer. So then to convert 4.7 kilometers, I know that 4.7 kilometers times 1 is equal to 4.7 kilometers times my conversion factor. So I'll put that in here. And now I've got kilometers up here and kilometers down here, so those cancel. I left off my miles there. That's important. So this tells me that's equal to 4.7 times 0.621 miles. And if I put that in my calculator, that's going to give me 2.9187 miles. So just a little short of 3 miles. So that's a nice moderate hike. For our next example, we're going to look at King Kong. An average male gorilla is about 1.7 meters tall and weighs about 155 kilograms. King Kong is about 50 feet tall, and this varies some, but 50 feet's a good approximation. How many times as tall is King Kong as an average gorilla? and also if his weight scales like volume proportionally to L cubed, then how much would King Kong weigh? So first we need to convert King Kong's height to meters to figure out how many times as tall he is as the average gorilla. So we've got his height in feet and the average gorilla's height in meters. And I know that 1 foot is equal to 0.3048 meters from my table. So my conversion factor, I'm going to divide both sides by 1 foot, is going to be 1 equals 0.3048 meters divided by 1 foot. So then to change 50 feet into meters, I'm going to take 50 feet times 1 is equal to 50 feet times 0.3048 meters over 1 foot. Now my feet are going to cancel each other out, and that's going to give me 50 times 0.3048 meters, which is equal to 15.24 meters. So that's how tall he is. Now I want to find out how many times as tall is King Kong as an average gorilla. So I'm going to divide his height by the height of the average gorilla, and that's going to give me my linear scaling factor L. Is going to be 15.24 meters divided by 1.7 meters, which is equal to 8.9647, or about 9 if I round that. So now let's look at what we expect King Kong to weigh. So I said that my linear scaling factor from an average gorilla to King Kong is L equals about 9. And weight's going to scale like L cubed, so weight is proportional to L cubed. So that means that King Kong is going to weigh the weight of an average gorilla, 155 kilograms, times L cubed, so 9 cubed. And that's going to give me 112,995 kilograms, or about 250,000 pounds. So that's a hefty gorilla. And that finishes up this section, the things that you should know. You should be able to identify whether a common unit of measure is a US customary or a metric unit. And you should also be able to convert a measurement given in one unit to a measurement in another unit of the same type. So distance to distance, area to area, volume to volume.